Okay. Storage basics. Now, the SAN, or you can say JBOD, okay, just bunch of this. SAN is known as the storage area network. Storage area network. We are going to access the storage over the network. So these components are nothing but a collection of bits that we are going to use. Okay, and those bits that we are using in the SAN or a NAS or a DAS can be accessed over the network, and it can act like a local bit to the server that we have mapped. Okay. On that particular logical unit, we can install Windows, or we can install Linux or any other operating system, or we can simply use it for the storing the data. So, what is the technology? What are the SAN components? What is NAS? What is the difference between the NAS, DAS, and the SAN? So, we will get it now. The first thing that we look is the DAS, direct attached storage. Okay? So, storage unit is what? So, as I told you, DAS is the basic building block in a storage system. Now, if you look at it, the name itself says directly attached storage. It is just like you are plugging the USB to your system. Right. And on this DAS or NAS or SAN, okay, it can support different types of bits. Initially, I have told you, right, these hardware overview, the hardware, that there are different types of bits. Okay, SCSI, DAS, okay, and FC. So the storage technology, mostly we will use DAS or SCSI, okay, or FC. FC is being more expensive. Okay. Now, the SAN is considered as a block level device. Block level device. Okay. Now, as we know that when we format the bits, okay, it will create a transient sector, and the sectors will have nothing but the blocks. Okay. So this is the same thing that we are going to learn. So DAS is something that we are not accessing over the network. DAS is the most basic storage system that provides block level storage, and it is the building block for a SAN and NAS. It is directly attached to a server or a workstation without storage network in between. Storage hardware. The performance of a SAN NAS is ultimately dictated by performance of the underlying DAS, whereas the DAS will always offer the highest performance level because it is directly connected to the whole computer. So this is what it is. Okay. If you see, we can use these types of hardware. Okay. In the coming pages, we are going to learn about those types of hardware. Okay. And moreover, we have to remember the type of protocol that is used for a Windows environment, for the Linux environment. Okay. Now, if I'm not wrong, we are using NFS4 and XMB. That is the protocol that we will use. Okay, each will be used. XMB, I think, is used for the Linux. Okay, And for the it is plain here. Yeah, SMB and NFS. SMB and NFS. NFS is used for the Windows environment and SMB is used for the Linux environment. If particular logical units mapped to the system where we are using the Linux operating system, then SMB protocol will come into consideration. And if you are using mapping logical unit, which is mapping to the Windows, then NFS protocol will come into consideration for transferring of the data. Okay. I will give you this document. Okay. So this is an example of the batch storage system directly attached. See, I've also spoke to you about the RAID. Okay, the only difference between the storage device like a SAN NAS, especially a SAN, and a server is the RAID controller card. RAID controller card. Okay, card. Okay. The RAID controller card will help you to will offer you the features like mirroring and sniping. Okay. If you have seen a motherboard, the motherboard will have the PCI slot, writer PCI slot. On that, if you need the additional card, the graphic card, you place on that PCI slot. Or if you need the additional network card, you place it on that PCI slot. Just like you get the RAID controller card in the monitor. Okay. And if you put that RAID controller card in your PC, then your server will act like a SAN. Like a SAN. Okay. And you can have a customized SAN inbuilt for your server. Suddenly you take this server, if it supports the RAID controller card, then we can make this server like a SAN, working like a SAN. Okay. Already this server will have a capability to handle more than one disk. Okay. It depends upon the number of the SATA ports. If you are using the SATA, if this motherboard is compatible for the SATA type of hard disk, you will have a SATA port on the motherboard, and that can support multiple SATA disks. So each SATA port will have a capability to support multiple SATA disks on one single cable and one single instruction. So the same feature that you will get in the ready-made SAN available with different vendors. As I've shown you today, the picture of the SAN that we used in our previous organization. Okay. Storage tech. Okay. Maybe we will have a look on the video. Okay. So in this, it will see. It can support the RAID controller card, can support SATA, SAS. PCI, it means this rate control card, you support the PCI slot. PCI slot, you have the this card on the motherboard, right? So this is what the rate control card is. So this is installed on the PCI slot. So right now it has only one bus. Now see, this is the ID drive. This is the ID drive. SATA, SATA, advertise SATA. Different types of this available. Okay, so this is array. So as I told you, the full form of array is within this array of independent text. Within this array of independent text. So this feature is available by default in the Linux operating system. Great feature is available. All the thing is like you have to add the others. You can make a logical volume first at the time of installation. And then you have to create the array. It's actually the software array. There is a software array that is coming along with an operating system. It's a software array. It gives you the same kind of features. But this is for the hardware array, where you actually have inbuilt rate controller card on your server. So it is organized, it has recognized two types of disks. Okay, so it's SATA and ATA. ATA is IDE, the white colored cable. Okay, so two types of disks we have. Sound which size up to 300 GB and 80 GB. Drive name, next. Where is your typing? So I told you about the typing. What exactly typing is? It's like, one job is done by two people. So half of the data is going to store in one disk, and another half of the data is going to be stored in the other disk. Basically, you're actually you're going to set the block size. Okay. Block. Some amount of blocks data will be stored in the disk 1. For example, 8 KB. 8 KB of data will be stored in the disk 1, and 8 KB of data will be in the disk 2. The disadvantage, the drawback of striking it, if any of the disk fails, so we lost whole data. Any of the disk fails, control. If any of the disk fails, then we will lose all the data. We lose all the data. The reason why we are using striking is for the performance. When we are writing to the two different disks, the performance increases. The data is being two different disks. The performance, get the performance. Mostly used for the people who love to play games, online games, or they go for range 0. Striking. See, RAID 0 for performance, RAID 1 for data collection. So what is RAID 1? Nothing. Like whatever the amount of data in the disk 1 will be copied to that. See, try 0 and try 1. See, this is for 64K. They are giving the block size, the size, database block size. Size of each block will be 64 kilobytes.
In one and then to yes.
Okay.
Once we write from data and one of it, then we go to another.
I think it will write parallelly. Make sure that the amount of data that is written to each disk. So there is a start point. So it is telling about the sum of operating systems, and it's coming with the RAID. So do we have to install the RAID software? Not at that time. As you saw, it is coming with the RAID serial. So either you can use this one or the one that is coming along with the operating system. We are creating the logical login. So it is actually raining again. Start. Linux again. Everything Linux. You see? And one by one, I think, now that they are using Linux, it is directing all types of Pacha, Raka. One software really is supporting Linux as well as Windows. Two different tools. That's the beauty of the Mac. That's the beauty of it. Okay. We will also have a look at the SAN. Storage. Yeah. So this is the hard disk this is the storage that I worked on. So it has 10 disks, each size up to 300 GB. Okay, and they are using SAS. They are using the type of the hard disk that we are using is SAS. The type of technology, just like we have SATA and IDE, we are going to discuss. Okay, IDE, what is IDE, what is SATA, what is SATA, SAS, ISW, standard. So, the storages, they have the rate controller card, they can support different types of hard disk, okay, and also they will have a specialized network card, okay, HBA, I told you about HBA, host to bus adapter, the advanced off network card. Okay. And the host bus adapter, they will use optical fiber. They will use what? Optical fiber. For the optical fiber to support, there will be different types of protocols as well. And there are fans that can support the Ethernet, network, as well as there are some fans that can support both Ethernet as well as the fiber optic. Okay, that type of fan is known as FCOE, cable over Ethernet, something like that. FCOE. It can support both technology, Ethernet and transit fabric. Fabric is a term used for optical fiber. So the orange color cable that you see here is an optical fiber. This optical fiber, and this is the Ethernet. This is really fun, you know. It's really fun. They have to connect in the fiber channels. This is called CAM, Common Array Manager. This is called what? Common Array Manager. So we are going to see how do we manage these channels? How do we manage? How do we create the manage? How do we create the logical volume? How do we create the logical input? There should be some control, right? There should be control. That control position can manage the SAN. So this different company uses the different types of web control. Okay. Sometimes storage Sun microsystem uses a web control called CAN. Common Array Manager. Okay. And some have something Kiboli. IDF servers they use Kiboli. Okay. So granite. Kiboli is also used for backup. It is also a backup. It also has some features what you use the backup.
Can it be in to that same location?
So this is the ESX. This is talking about the VMware technology. All we are bothered about is web console. It is the same kind of feature is available in OpenFiber. But it's free to download. And you can create this web console just like this. Alright. One more thing. A Linux operating system can also be made to work as a SAN by installing some specific protocols. For example, we want the SAN as a scheme practically, the state controller can support the ID class, ID, as well as the PANA or SATA, whatever. How it is supporting this? It is employing the drivers that support that kind of hardware. So, Linux operating systems offers, they have special packages. If you install those packages, okay, then it will act like a SAN.
They have
Special drivers. Okay. Alright. Thank you. I want to show you the
username website. Why not do it yourself?
This is the software that can be downloaded easily from the Oracle.com. But it is compatible only to the storage devices. You cannot Right. Anyway, we'll go back to this. Yes, you can create logical groups and logical volumes and map those logical groups to just any of these or any of these things. Particular users, but because it is acting like a local disk to that particular host that we are mapping. Say we have created a logical volume, LVM. Now LVM, we want you to map this to some other host. So that host, we have Windows and it's going to be a Linux. Okay. And that particular host will be able to see that this at a local level. For both users, we plan. Particular GB. Okay, I'm going to show you particularly. Okay. Now, it will be common for both the users. Yes. So, any number of computers that we can run. Okay. You will see that. Okay. So you have the client computer system. Okay. You are using some applications for which you are accessing the file system, the volume manager, and the disk system, device manager. And you have finally the HBA card for the laptop. So these words are the different types of technology. The charging is called, it is pronounced as charging, SCSI. And the pronounce is SCU double ZY. Charging. Okay. So charging means small computer system interface. It is one of the oldest common storage interfaces, traditionally used in server or workstation class computers. It has been through many revisions where you have different versions in charging. Okay. So these recent versions can handle up to 15 hard drives. So when the storage has the disk, if we are using the starting disk, then it can handle up to 15 disks. Not more than that. It can handle up to 15 disks. The storage, the collection of disk, right? The one that we are using starting disk in the enclosure, then it can handle up to 15 disks, 15 hard drives.
Carrying the hard disk.
Charging the hard disk. Charging hard disk and the charging technology, okay, can support up to 600. It means that there will be drivers will be there for that to run that charging hard disk, this charging drivers. Okay. So, and this particular protocol or driver can support up to 15 hard drives. How is it? See, for example, you plan to purchase a fan for your computer, for your organization. Okay. Now, it depends upon the budget. If your data is saying in petabytes, something like that. Okay. Starting would be the oldest and the cheapest solution. Oldest and the cheapest solution. And if your data goes, for example, maximum I think one disk will be sized up to 300 GB. 300 into 15 is how much? Approximately 4.5 up to 5 terabytes. So the SCADA technology you can say it can support up to 4.5 to 5 terabytes of data. Okay, but if you have the data which is in petabytes or exabytes, then SCADA technology is not suitable for it.
We have 5
One is parallel advanced technology attachment. Serial, just like we have a serial ATM, this one, and it has a pin. It's the parallel advanced technology attachment. Sometimes known as IDE or attaching. Okay. Since we saw the video just now, we go through the IDE, so you were selling a partner. Okay. So this is that. Was the most dominant desktop computer storage interface from the late 1980s until recently when the SATA interface took over. Okay. SATA took over by the SATA. SATA hard drives are still being utilized today, especially in the external hard drive boxes. But they are becoming rare. Some cheaper high-end server storage devices are also known as SATA. SCADA has also gone through many divisions. The most recent division is SATA. SATA is UDMA 133, which is mostly used in the external hardware. Okay. Now, although SATA supports 2 devices per connector, in a master and slave configuration, the performance penalty of sharing a SATA port is severe and not recommended. So performance is important to the user. It has a 40-pin connector and the cabling is also extremely wide. It is difficult to use in a high density environment and tends to block proper airflow. The size of the connector also presents problems for a smaller 2.5 hard drive which require a special shunt connector. The disadvantage of this SATA is the wide, the bigger 40-pin connector, which actually doesn't allow you. It has special SCADA connector. Let's see, this is probably hardware. Okay. So this video actually talks about what exactly was parallelism. This video talks about how to identify which type of projects you have. So we are looking for, let's say, hardware. generally it will be in the storages. Okay, here you can see again the NAND interface, this is the interface that you see. 50 pin. This is 80 pin. Okay, just like we have ID, we have the SCSI. Okay, this was the serial ATM data is officially successor to SATA. So far there have been two basic versions of SATA. SATA 150, SATA 300. It means it can support up to 300 hard disks. The numbers 150 and 300 represent the number of MB data interface support. SATA doesn't have any performance problems with cable port sharing. Okay. But that's because it doesn't permit sharing at all. Okay. One SATA port permits, actually 150 and 300 is actually represent the number of MBs. Number of MBs in data, or it cannot support multiple hardware. The Ultra 320 SCSI, which we have controller that allows 15 devices to connect it. Okay. The upside is that each drive gets a theoretical 300 MB. Basically, the SATA is mostly used for the workstation, not for the storage. Okay. Whereas SATA and PATA, SCSI was more better. It can support up to 15 minutes. Right? Now, next, the combination of SATA PATA is something called SAS and SCSI. Serial attached SCSI. SAS means serial attached SCSI. The advanced version of SCSI is SAS. SCSI is the latest storage interface that is gaining dominance in the server and storage market. SAS can be seen as a merged SCSI and SATA interface. Okay. SATA, what was the advantage of the SATA is it can support, with one port, it can support up to 2 devices with a capacity up to 300 MB of data transfer speed. Okay, whereas the SCSI can support up to 15 days. Right? Because SAS is a combo of that. Right? That means you can connect SAS hard drive or SATA hard drive or CD or single-ROM on a 1 hard drive. SAS has a signaling rate up to 115 MB. Okay. But storage controller technology has historically been rated by actual data throughput that is lower than the signaling rate. To make these numbers comparable to the numbers said above, the actual data rates are this one. But this is very good actually. SAS connectors are keyed such that the SATA devices can connect to SAS and SAS devices connect to the SATA port. And the port and cabling look similar, but SAS cables can be 8 meters long. Okay, whereas SATA cabling is limited to 1 meter. SAS is designed for high-end server and storage markets, whereas SATA is mainly independent for personal computers. Unlike SATA, SAS can be connected for multiple hard drives through expanders. So SAS have seen SAS as a SAS hard drive. Next we have the touch scene. Fiber channel is both direct connect storage interface used on a hard drive and a SAN technology. FC offers speeds up to 400 bits. Native FC interface cards drives are found in very high-end storage range using SAN as a deployment. Okay, all the technology may ultimately give way to a SAN. So, Flash is again, this is actually SAS is again I told you, SAS it is a purely fiber optic. Purely where the data will be transferred at the speed of light. Yeah, 400 MB offers speed in the speed of light actually. The cable that we use is different. Whereas here that we use some different kind of cable. Subsea cables and all. This is a bit more on your turf. The flash memory is mostly used in exadata machine flash memory. Flash memory kind of thing. Exadata machine. Exadata have you heard? It is an Oracle engineered machine. What exactly it is? The benefit of taking the exadata machine here, you don't have to order server hardware or operating system or rack separately. Everything is coming as a one-stop shop. Okay. In that we are using flash memory. So what is the flash memory? It is a storage interface, but it is used for very high-end storage applications because it doesn't have the mechanical latency issue of the hard drive. Mechanically latency issue. I mean, when the hard drive, when it wants to write the data, it will write the data in different blocks. Some data will be available in some other sectors. It will not be sequentially read. I mean, though it will be sequentially read, but it will have the address of the block that is available in the nether sector. So that actually brings the problem of latency, slowness in reading. This is called data contention. Flash memory can be packaged into the shape of a hard drive with any of the above interfaces so that it can be used in a storage array. The benefit of flash memory is that it can offer more than 100 times the read input-output per second. When you purchase these hardware, you look for the RPM, rotation per minute. RPM. While for the flash memory, it is the input-output per second. So the downside of flash memory is that it is very expensive per gigabit. So cost is very high and it has a limited number of writes and rewrites. Flash memory will begin to fade anywhere between 10,000 to 1 lakh writes. To deal with this limitation, flash devices will use mechanisms called wear leveling to spread out the damage so that the device will last longer. But when it has its limit. Then you can just read on your own what exactly the flash memory is. SAS. Going cheaper is SAS. It has a combination of both SCSI and the SATA. And when you go to any HP website, for example, or you want to buy a SAN 6140. you go to any specific vendor, it will give you the whole information. Okay. It has 4 and 2 interfaces with the fiber channel. Okay. Total direct capacity is 12 terabytes. Hard disk direct external interface plugin only. It can support different types of arrays. Hard disk plugin module. Okay, one more thing I would like to tell you is that all of these hard disks will be hot swappable. Hot swappable in the sense when you can remove and replace the hard disk and the running condition. If the hard disk is corrupted, you can replace the corrupted one. The damaged one with the new one. How it will work? Example, imagine this has a capacity up to 16 hard disks, right? The source cat is 16. What it is 16. So 16 into 750 GB means each hard disk size will be approximately 750 GB. Each hard disk size. 750 into 16 is how much? Maybe okay, so something better I would say. Now, out of 16 GB, you can keep, for example, 2 hard disks with a hot spare. Okay. Now, hot spare is like stepping your car. If any tire got punctured, you can easily replace the punctured tire with the stepping. Same way here. Okay, you have the hot spare hard disk, and you can, if any of the hard disk is damaged, then the data of that particular hard disk will be moved to that hot spare hard disk, and you replace it with a new one, and again data will come back to that particular replaced hard disk, and those hard disks will become again hot spare.
Data which is there in the standard context, how does it become
automatic? The purpose of the hard spare is for that, to to avoid any data loss. In the software it will come. The software will whatever the SAN that you are working on. You have to read the manual. The manual will tell you how to use the hot spare and how to. You can create as many as hot spare disks for that particular thing. So these are the SAN concepts actually, which I'm giving the idea. So that if you come to work on some projects, and you happen to work with the SAN administrator, it is easy for you to tell them. So this is what it is. So the advantages is in a DAS system, the storage input is dedicated. Outside the solution is inexpensive. Disadvantage, DAS has been referred to as a highland of information. DAS includes its inability to share data or unused resources with other servers. Both NAS and SAN architecture attempts to address this problem. We introduce some new issues as well, such as high initial cost, manageability, security, and contention of storage source. Blah, blah, blah. Okay. SAN. Okay, NAS and SAN are two ways of sharing storage over the network. It offers high-level functionality than DAS because it connects multiple ports, multiple servers to connect. Okay. SAN may use FC or Ethernet, ISAB or AOE to provide connectivity between host and the storage. Okay. And SAN is very useful in the clustering environment. That's why for the rack, you will use SAN, you will not use DAS. Okay? Where a primary server might fail and a backup server has to take over and connect to the same storage volume. Because the SAN offers a block level storage to the host, it pulls the application into believing it's using a DAS storage system. Basically, the name host that is being mapped, the nums that being mapped to the host, we assume that it's a local name. So it pulls the host. Okay, so these are the points that you see are connecting via switch, Ethernet switch. What you see is a Ethernet switch. Okay? There you see. So this is the Ethernet switch. These are all the Ethernet cables that you can see. Okay. But the brokerage switches, okay, are specially designed for connecting to the SAN. So here, the FC switches. These are the SAN. The SAN will be used for the fiber optic, even the fiber optic. They will only use the fiber optic. However, the some SAN will be there will support Ethernet also. They also have Ethernet card. Okay. Maybe we check the specifications here. It is supporting the RJ45. RJ45 means it is supporting the Ethernet network, as well as it is also supporting the fiber channel, which is the HBA card. Understood? Alright. So this hard disk will support fabric switch, because the fabric disks, it will support the fabric switch. So all the HBA, it will have the HBA card and it will connect to this brocade switches. It's a company called Brocade, which is specialized for the fabric connection. So the SAN is often built on dedicated network fabric that is separated from the LAN. Okay. So, yeah. Remember this, as you have seen about normally the client will be connected to the host server. Okay? Via public IP, which will have DNS cable, it will have Ethernet cable. Okay? And this host server, it will also have the HB card. Okay? That will connect to the SAN directly. Because we have mapped the lines, right? Or mapped the logical unit. To support the logical unit, this host should have the HBA card. Okay. This HBA card will connect to the fabric switch. Connect to this fabric switch. The fabric switch will finally connect to the storage. So between the client, you have the Ethernet switch, just like this. Okay. And we are connecting to this server. This is like a rack 1 or rack 2 server. Okay. For our Oracle rack environment. And these rack environment will connect to the fabric switch. And the fabric switch will connect to the storage. You see, you will have the answer. You say that in common terms, that is called an Ethernet switch. It can support only Ethernet. Okay? Why Ethernet? See, and why we are using the fabric for example, for faster IMAX. For the users for general transaction, we might also use the fabric switch, but it will increase the cost. Why would users need the fabric network? Fabric network is used for the higher availability for some purpose. If any server is not working, you have some default, and other servers will be available for the user to connect. The timing is very explainable. SAN, okay. The same thing that I was explaining you again. So these examples show the dedicated SAN network connecting servers, okay. Application layer server on one side, and number of disk systems and tape drive systems or other. The servers and the storage devices are connected together by a SAN as a field. The SAN fabric ensures a highly reliable, low-latency delivery of traffic among the fields. Okay. The SAN software architecture required on the computer systems shown in the figure 6 is essentially the same as the software architecture of a DAS system. The key difference here is that the disk controller driver is replaced by the fiber channel protocol stack or the iStatic ECPM stack that provides the transportation function for the block I/O commands to the remote disk system across the SAN network. Okay, using fiber channel as an example, the block I/O static commands are mapped into a fiber channel framework, FC4. So these are the different technology that we use in fiber channel. Okay. Maybe you have I would suggest you to have a bird's eye view. Bird's eye view. Okay. So when we have a bird's eye view, you will have first understand in a general term. First, you understand the general term. Then you dive in internally. Okay, when you read this document, once or twice inside, okay, then you will dive in internally. Okay. Because, I'm giving you a general overview. My objective is to give you a general overview. I cannot give you more in deeper. I can also give a deeper, but it's not required at this point. It is just to understand what is what. Okay, in interviewer, they ask you, they will not ask you anything, but you will have to, if you understand technology, being as a product manager, being as a team leader, we will tell you what is what. The company is investing on infrastructure. If they are investing in infrastructure, what kind of SAN they are offering, so they are ordering, then bring it to their organization. You can see each and every component. Okay, basically, so this is the application through which you can connect to the SAN and can support high-security protocols, TCP/IP, and the SAN you will have both HBA as well as the normal network card. And it connects to the HBA to HBA. This is the client, for example. It connects to HBA to HBA and network to network card. This will be for the public and this will be for the private networking. Okay. So it has been the SAN technology used FC, okay, and SCSI, AOE, ATA over Ethernet. Okay. Let's go through this. Advantages, okay. Now, if you read the advantages, sharing storage usually simplifies storage administration and adds flexibility since cables and storage devices do not have to be physically moved to shift storage from one server to the other. Other benefits include the ability to allow servers to boot from the SAN itself. Okay. This allows for a quick and easy replacement of a faulty server, since the SAN can be reconfigured so that the replacement server can use the NUN of the faulty server. The NUN which is being used can be reused on a new server. The SAN could span a distant location containing a secondary storage current. This enables storage replication either implemented by display controllers, by server storage, or by specialized SAN devices. Since IP WANs are often the least costly method, okay, which is Ethernet, and is a costly method for long distance transport, the FCOIP, the fiber cable over Internet protocol, okay, and ISCSI protocols have been developed to allow SAN extension over IP network. But traditionally, physical SCSI layer could only support a few meters of distance, not nearly enough to ensure business continues in a disaster. It seems that IP is not suitable for a disaster. Okay. Fabric is mostly used for the disaster, to work on the disaster.
Normal production
It could be fiber optic. Could be the Ethernet cable also. It depends on the company how much they want to spend money. Nobody will tell you actually. First of all, being as a DBA, being as a project manager, yes, you have to know this thing. So being as a DBA, you might be able to get the about what has exactly happened in the background. Okay. So if you work in an organization as an in-house DBA, for example, you travel to the Middle East or to say America, Singapore, so you will hire as a project manager. Now, you have to see the first company's requirement, what exactly the company wants. You will approach Oracle support to get some advice and then the company will plan. Or else some Oracle partners who can advise you and give you the best solution for the company's requirement. Then, as we have seen, the proposal initially showed, right? The SAN proposal. Okay. What like Arabic Computer System was a vendor who was an authorized Oracle partner. They provide the solution on behalf of Oracle. Either you want to go directly with Oracle to implement the Oracle project, or you want to go with the Oracle partner. Either way, they will give you the solution. Option 1, option 2, option 3. Option 1 has this feature, option 2 has this feature, option 3 has this feature. Same, you propose this project to the company, and that's it. They will give you the demonstration. The vendor will come and give you the technical knowledge one by one. Free of cost. If they get the project, then they earn millions. That's why they have to demonstrate. Because how would you, being a project manager, how would you suggest your company that this solution is best? You never personally does that, and it's not a good practice to personally suggest. Even if they ask you, you can say the Oracle is best. But to take it automatically. The Oracle is suggesting for your requirement, this is simple system. Now, company is thinking of some economical solution, some thinking of the budget. There are always two or three vendors. They give you different proposals for the same solution, which will cut the cost. And then you will make your approach. All the vendors they will do, they will send their engineers. First the hardware will come. Then the hardware engineer will come and they will start the server, configure the server, mount the rack, place the server, installation of the operating system. Again, installation of operating system will be according to your planning. Then nothing of plan. The plan comes, nothing of plan. Will form a team, will conduct a meeting. With all your network administrators, hardware administrators, locally as well as the vendors. Vendors, when if you are giving a project to a vendor, the vendor engineer will come and they will do the task plan. Let's go. Implementation quickly if you take the hardware from them. Something, the solution like that would be there. And knowledge transfer. So that's how you will learn and upgrade yourself. Meaning higher position is always not very good. SAN is all about, sharing the resources, the host. Okay. Disadvantage is very, very expensive. The disadvantage is very, very expensive. And maintenance requires high degree of skill. You need a separate skill set and it is very much in demand. Leveraging of existing technology investment can too much difficult. Though SAN facilitates to make use of already existing legacy storage, lack of SAN building skills has greatly diminished deployment of homegrown SAN. So currently pre-packaged SAN based on fiber channel technology are being used among the enterprises. Okay, packaged SAN, ready-made SAN. Management of SAN systems has proved to be a real tough one due to various reasons. Also for some, having a SAN storage facility seems to be wasteful one. At last, there are few SAN product vendors due to its very high price and very few mega enterprise need SAN setup. So only few vendors are offering this high-end SAN setup technology. So SAN is equally suited. When I was in Dubai, in Saudi Arabia, people suggested me oh my goodness. So storage in cluster. This is a mind-scratching game. 8 million. Clustering, if you want to run data cluster as well. Example, we have some rack cluster, we have some cluster, we have Veritas cluster. So, maintaining the database, keeping the database available to the business is one of the important crucial points for these days the companies. That's why they are running up in such a mission critical technology. You have to. It is available. No other choice. So NAS is file level storage. Now the only difference between the SAN and the NAS is the SAN is a block level storage device and the NAS is the file level storage device. This is just like you are sharing the folder. Sharing a folder networking. If you want to share your folder, you right click on share your folder. Other people will be accessed, right? So that's called file level sharing. Okay. So NAS uses different types of protocol, which is SMB and CIFS. There we are using SMB and NFS. Okay. NFS for Unix compatibility or Samba for both. Okay. Anyways, we will talk about it. It's basically another name for file server. It's nothing but the NAS, nothing but the file. Sharing.
Okay.
So NAS devices are usually just regular servers with stripped down operating system that are dedicated to file serving. Although it may be technically be possible to run other software on a NAS unit that is not designed to be general purpose server. For example, NAS units usually do not have a keyboard or display and are controlled and configured over the network, often using a browser. A fully featured operating system is not needed on a NAS device. So basically you will see the advantages. The difference between NAS and SAN is the file level I/O, while SAN does the block level I/O over the network. Data is transferred across the network to the recipient in blocks directly in SAN. Okay, over the network it is being transferred over the block, data block. Whereas in file data stream it was processed from the data block, the file layer. So NAS is particularly ease of use when compared to SAN. Many operating systems Unix and Linux have embedded support for NAS protocols such as NFS, okay, and CIFS. Basically, you can develop the NAS as well as the SAN. You can actually install the rack on NAS also. Okay, file-oriented access also make it easy to implement a heterogeneous network across multiple computer operating system platforms. So NAS can be compatible for either type of operating system. Okay. The benefit of NAS over SAN or DAS with multiple SANs can share a single volume, whereas SAN and DAS volumes can be mounted by only a single line at a time. NAS device allows administrator to implement simple, low-cost, load balancing and fault tolerance systems. Disadvantage. The downside of a NAS is that not all applications will support it because they are expecting a block-level storage device. NAS is a cheap and best solution, but it is not supporting the block-level storage. And most clustering solutions are not designed to run on a SAN. Besides, the backup solution is more expensive than the storage system. And even any construction is the local area network will slow down and storage access. So the only thing the NAS is disadvantage is not the block level storage device. Okay, it is not suitable for the clustering environment. Otherwise, it's the block level storage. Okay, can support for multiple operating systems, but it is not support for the clustering environment. That's why we have to forcefully go to the SAN itself for the clustering environment. So this was all about your storage technology.